let's start the recording. I will go ahead. All right, so with regards to so you probably all got a dump of email alerts last night. So again, what happens is that I send out I combine the two grade books, and after I do that, basically all those grades get imported all at once. So I want to clarify a few things from just kind of most important. Well, they're all important to you. So anyway, first off, if you got a unsatisfactory as a midterm report, you should know that I have an itchy trigger finger where that's concerned. I am more likely to just simply execute that on vibes, I guess is the best way to put it. I will, generally speaking, I look at your grades, and if your exam grade is below a 70, I send out a unsatisfactory G, because that puts you at risk of being beneath, doing worse on the future exams. So, and I'll explain why I'm like this in a minute. If you're missing a bunch of the runestone stuff, and that's very low, I'll send out a grade missing, or a assignment, an A or an M, whatever. But basically just to notify you, hey, you're missing this stuff, because if you don't do it, it's like 10% of your grade you're throwing away, right? And if you don't do anything, if you've been completely missing from class, that's a AGMP, so attendance, missing assignments, participation, and grade issues. So if you got an AGMP, then most likely be very worried, unless you know not to be. But the reason I'm kind of aggressive on the unsatisfactory reports for this is because it literally has no effect on you, other than giving you a big warning. What I mean is that, I'm an advisor. When I go in to see your grades, to see your transcript, I cannot see that you got a satisfactory or unsatisfactory on for the midterm evaluation. It carries no future weight to shoot these out. So I'd rather accidentally give some students some additional anxiety for being for a false positive than accidentally miss a student who needed to be warned that I might be able to intervene in. Okay, that's basically the logic behind it. Sorry if you got that, and it's also possible I'm wrong, because I'm working with tiny little drop-down menus, and it's so easy to miss somebody else's name. I double and triple check when I'm putting in final grades, but for this stuff, I just check once. So. The runestone stuff. So because I needed to have this midterm in yesterday, what I did is I graded the runestone stuff, most of it on Monday, some more of it on Wednesday. What this does, so I just want to be clear here. This does not mean your grade is frozen. It might be temporarily frozen, but it will be updated next time I run the grader, right? The way it works is that I go over to runestone. I'll show you how it works. You go over to runestone. I log in as the professor. Okay. And this is how it works on runestone. You saw how it works the other way, where I combine the grade books to upload it to Canvas once I'm done with this process. But what I go over here is I go to the instructor dashboard, and I go to the grader. And then what I do is I select the assignment I want graded, uncheck this box so that late work is accepted, and then I hit score these questions. And then the reason I'm not doing this is because it would show the names of the students. That's why I'm not scrolling any further down, but it's currently going through and grading all these. So if you had changed that between when I graded it, so if you had done the chapter 1 readings between when I had run the grader on Monday and right now, it would be updating your score. So your score just won't update manually after the grader is run on these assignments. But don't worry, if you do it, you're getting the credit for it. The reason I had to run the grader is because I needed an accurate snapshot of where you were now. Okay? Makes sense? So don't freak out too much if your grade took a dip, because that's fixable. It's very fixable. Okay? It's super duper fixable. Same thing for the in-person assignments. If you did, if you missed one of the in-class assignments, one of the project or whatnot, yeah. And if you were there and should have gotten 100, let me know, so that, because maybe I had a question that's being scored that we didn't do in class, right? Sometimes that happens where there's a question left over from last semester that we got to, but I didn't get to this semester. And then that's counting as being scored. If you've been doing this stuff on Runestone and you've been doing it and you're like, yeah, I'm on top of things, and then you proceed to get 0 and everything, please let me know. There's a few conditions where that can happen, such as having an extra account, your name's not matching, just a whole host of situations. It's generally like 2 or 3 students a semester. I do try to give you instructions so that it won't mess up, but things happen because computers are weird, and people are weird, and names are weird. So, yeah. So, suffice to say, if you do the work, I'm going to give you the grade. Don't worry about it. Again, this is just kind of to kick you into gear. Speaking of kicking people into gear, last night I sent out a very scaring email, and you may have seen that via Discord. I got it myself, and so did the TAs, because we hadn't done Lab 4 and 5 ourselves. But anyway, it was basically saying that you're at risk of an F in the course. You will have gotten this if you do not have a grade for Lab 4 and 5. If Lab 4 and 5 are graded, you will not have got this. It's one of the things I can do on Canvas. I can basically go to an assignment and send an email to people who haven't turned it in, or people who haven't received a grade, right? So if you have not turned that in, you need to have this turned in and demoed by the 18th. Please demo it in your lab on the 13th or the 16th, and if for some reason that is not going to work for you, then email me so I can demo it for you ASAP. The reason being is that if you cannot have this demoed to me by the 18th, you have fallen so far behind in the course, you're doomed, right? So please demo that. The reason I say that is because you need to have the time to make these mistakes, to make these errors. Some of you experienced that already, where you've been bashing your head against something for like 3 hours, okay? And then it was a simple mistake and you fixed it, and now you're never going to make that mistake again. Or if you make it, now you can fix it in like 2 minutes, right? This is a common thing you have to do in programming, and now we are kind of, if you have not done anything in this course, you're kind of out of time to do that, right? So this is why I'm just trying to save you basically a bunch of stress and pain by saying, hey, you're going to auto-fail, so just drop the course, okay? Because it's just not worked out, okay? And you're certainly not going to be prepared for the next course, right? It's in the syllabus on the second page, basically the week 8 deadline. So I've set that for 11:59 p.m. on Wednesday the 18th. If it's not demoed in, I will go in and basically, so if you don't have a grade for that assignment when I wake up on Thursday, I'm going to go into the assignments and I'll put in a negative 1 million for your score in that, and that will take care of that. It works. It works like a charm. Like, I can give an assignment a negative grade. That's typically, in case you're curious, that's typically how I alert people. That's how I mark down somebody I need to put down as a cheater. Generally, that sometimes that gets them to reach out to me first, which is very useful. Anyway, so with regards to your next exam, that will be on the 3rd or the 6th, depending. So again, if Passover is an issue for you or some other religious holiday, let me know, because the Wednesday is Erev Pesach, and so first day of Pesach and second day of Pesach would be a Thursday and Friday. So if you have any kind of religious issue, just let me know in general. So hopefully I've answered everybody's questions about that, and now I can just simply redirect those emails that I got those 2 emails I got last night to this lecture. Any other questions about the runestone stuff, the assignments, the lateness, that kind of thing? All right. So today what we're going to talk about are one of my favorite tools in Python and in other programming languages. I kind of talked about them in previous semesters, but like for loops is one of those things that is super useful to talk about. And I find the most interesting way to do it is to talk about it in terms of a problem that we need to solve. Okay, so what we're going to do over here is I'm going to create a new file, and I'm going to call that file, let's see, where am I going to put this? I'm going to put this in, again, I need to put this in my file, in where I have a file to read. I've still got my pg100.txt, so I'm going to use that. I'm going to call this letter frequencies, right, .py, okay? And the reason I'm doing this is because I still have this Treasure Island, right? I still have this Treasure Island file that I'm going to download. And you can use any file on your computer to do this, okay? I'm just going to use the Treasure Island file because I have it. But on Tuesday, we were talking about word frequencies and Zipf's law. Basically that languages have markers, right? They have that something with a language, something that is a language have words, and these words occur more frequently than others, right? I'm sure this is true for all languages, right? Where some words are just plain more important than others. Similarly, languages also have a marker of sorts to tell you, that kind of help you identify what language it is, with the frequency of certain characters appearing, right? So French has a certain kind of distribution of letters. English has a certain distribution of letters. This is just the way it works. This is why, Wheel of Fortune, you'll get, like when you're doing the final word, it gives you RSTLNE, I think, right? It gives you those letters, and then you're asked to get 3 more letters in a vowel. They may have changed it, but that's how it was when I was growing up. But that's because these words, Itoen is a good acronym for it, these letters appear more often than others, right? Letter frequency, English. Right, so here we see that E is the most common letter in the English alphabet. Itoan. Sorry. So ETAONRISHD in terms of commonality, with Z and Q and J and X being very uncommon. These are also why these are the high points in Scrabble, right? Because they are very rare letters. So hard to make words with them. Okay. Note that it's it's making references here to codes and secret writing. Right. This is all about. Basically, this is a very useful tool for analyzing analyzing things that are encrypted. Right. This is also why you choose if you're playing Wordle. Right, you'll start with certain words over others. I'm a fan of using my first 2 guesses to try and not making a first word, but using my first 2 words in conjunction with 4 kind of real guesses left. I'll often do something like Talon as my first word, and then cruise as my second word. Even though that's not necessarily super efficient, but it helps because I've got a spread of 10 letters then that let me really narrow it down. It works like a charm. Okay. Also note that this says text versus dictionaries. This is basically, okay, are we doing an analysis of a bunch of text versus are we going through every word in the dictionary and counting letters that way. Like we see that W comes up more often but appears less often in words. Okay. So how can we build such a count for for our file Treasure Island? Well, the first thing I have to do is open the file, right? So we already know how to do that. Data is equal to open. And the file we're looking at is pg100.txt. And because this is because it's from Project Gutenberg, just because I've done this a bunch of times, I have to use this whole encoding is equal to UTF-8 thing in order to get it to work. Otherwise, it just vomits on me if it's a Windows machine. Not PG100, PG120. Right? So you can just follow along. You can use any file, including a Python file, to do that. Right? You can read a Python file. There's nothing stopping you. Okay? And then, because I could read, this is one of those instances where I can just do this. Text is equal to data.read. Because since I'm doing a letter-by-letter count of this, print text, what is going on here? Text, colon, let's do with 5,000. Print the first 5,000 characters. Right? Because I am just simply reading all of the entire file and I'm going to be going one letter at a time, right? Then all I have to do is just go one letter at a time. I don't need to split it up into lines. No need for that. Just can make it one mega string, right? So there we go. So I've got this data. Now the question is, I want to find the frequency, what the most frequent character is, and I want to find out like what percentage of all characters that is. Okay? So how can I do that? Well, I need to count. So let's think about this for a second. With the tools we know, right, if I'm trying to find the most common letter, there's a couple of naive solutions we can do. Let's go with the this is dumb, but I know it's going to work kind of solutions first, okay? So for letter in text, and I'm a big fan of this is dumb, but I know it's going to work for kind of figuring out our first thing, because it's a good proof of concept. Right? If letter equals A, then A, let's go, I'll call it just A is equal to 0, B is equal to 0. Oh God, now you're seeing what I'm doing, right? C is equal to 0. Don't copy this, this is terrible. Okay? Dot, 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 dot. Okay, so if letter is equal to A is equal to the number of A's I've seen plus 1, right? And then we just simply copy elif B. Okay, B. So this is kind of terrible because, but it will work, right? You've just got to copy paste this 26 times, right? You got to create 26 different variables, okay? You got to create 26 different variables, and then you got to count them all. But God help you if you also wanted to count the number of spaces or the dashes or something like that, right? Then you'd have to add that in as something to count, and you'd have to basically manually adjust every single variable, which stinks, okay? So let's toss that idea, and instead let's go on to the next one. Next idea. Well, same idea where we do 4-letter in text. Okay. The idea here is that is to be a bit smarter. I'm going to create a counts variable, right? And then this is a bit tricky, but I kind of have an idea of how to do this. I know how to do this. It just takes some explaining to do. Okay? So first off, we got 26 letters over here. So I'm just going to create this, which will be a array with 26 zeros. Sorry, a list with 26 zeros. Getting my languages mixed up here. See, it's got 26 zeros here. We have 1 0 for each letter in the alphabet. And what I'm going to do is I'm just going to kind of say, let index 0 be the number of A's. B is 1, index 1, the number of B's, and so on and so forth, right? So a bit more compact here, right? So I've got one variable, 26 letters, and 26 slots in this. And so what I can do now is I can say, hey, 4-letter in text, if, okay, and we could, start out by doing the same kind of idea, that dumb idea we had. If letter equal A, counts of letter is plus equals 1. So increment that by 1. Then we just simply do that for B and C and D. So again, 26 if statements there. But, sorry, not letter. 0, 1. Everybody get the idea there? I think I think 3 makes a proper pattern, right? So we'll do 3 here. C2, and this wouldn't take too long, but it's certainly tedious. Definitely not elegant. Okay? And then if you also want to track the capital letters differently, we're going to be in a world of hurt, right? Because now we have 52 letters to kind of do, and that's a pain. So let's try to figure out a way to automatically do this for us, okay? Can we automatically basically say, hey, if I have figure out based on what the letter is, go into if we know what the letter is, can I send this kind of to the index it needs to be automatically? And the answer is yes. We just have to make use of something that I mentioned once, weeks upon weeks ago, and then promptly never used again, because I'm totally that guy. And will you need to know it in this course? No. Sorry for everybody who's watching late at night, and your screen just flashbanged you. So we have this really cool thing called the ORD command, which given a letter, gives you the ASCII value of that letter, the numeric value that that letter is stored at in ones and zeros. Lowercase a is 97, okay? And so, to cut to the chase, if I've got a letter like R, O-R-D, I can figure out what index I want to put at by subtracting A from it, essentially. And that would be, so R is the 18th letter of the alphabet, so I'm going to put it into index 17, because the indexes are from 0 to 25, right? So it's off by 1. Or for a more easier to understand example, Y is the 25th letter of the alphabet, right? Y is the 25th letter of the alphabet. Its value is 121. which is more than, well, it's 25, it should be 24 more than 97. So it's the 25th letter of the alphabet. It goes into index 24. Does that make sense? Right? What we're going to do is just simply, the indexes range from 0 to 25, right? That's my range of indexes from 0 to 25. Okay, so we've got 0 to 25 inclusive. That's my range of indexes. But when they're stored as ASCII values, as numeric values on the computer, that range is 97 to 122 inclusive, right? So what we need to do is that we need to take this over here on the right and convert it to the value on the left. And the way we do that is just by subtracting 97, which is the value of A. So you don't even have to remember A is 97. You just subtract A's value from this, okay? So what that looks like in principle is index is equal to letter. We go to this letter, go ORD, letter, okay? And then I'm going to leave an error in here. We're going to run it. It's going to crash. Then we're going to fix it, okay? So index, order, letter. And then this is basically, we replace this with not even an if statement over here. We would just simply go, hey, the counts of this, the counts of this index is equal to, is incremented by 1. And that should do that for now. Like I said, I'm going to run this and we'll get an error where it says we get list index out of range. And the reason that it got out of range is because we forgot that there's other characters than besides our 26 letters, right? ORD letter minus ORD, forgot to do this, ORD A, the entire point of this, the whole subtracting A from this value, right? So same error still where we're getting the index out of range because there's more than just the 26 letters here. We have periods, semicolons, that's not gonna, right? And so for instance, say we've got ORD and we've got a period, that's 46. So if I subtract 97 from that, I'm going to get a negative index. And that negative index is going to be way out of range on the negative, so that's not going to work either. So what we're going to do here is actually a very simple if statement, which is going to say if index is, if our index is in a valid range, less than or equal to 25, it's greater than or equal to 0, but less than or equal to 25. As long as it's in the range of indexes that I'm going to accept, great. And now, hopefully this should now work. If we have an error here, it's unforced at this point. Unindent does not match indent later. That's me. See? Make that issue there. Okay, and so now we've got a count of characters. Now let's go ahead and just print that nicely. I'm going to go ahead and move this out of the way so that we can see with our own eyes just how short this code got with some thinking and some magic and guidance, right? Once I reminded you that we have this tool that existed. And we have these two prints here, one of which is unnecessary. It's your before and then your after. So let's go ahead and what we'll do is we can just simply print all these. For I in range, length of counts, we know how long counts it's going to be. It's going to be 26. But what we're going to do is we are going to basically say, we have a function called CHR, which is the reverse of ord. So it takes a number and converts it into a character. So what we're going to do here is I'm going to print, well, first what I would do is I'd print counts at I. I'll go ahead and be explicit that index, because I used index earlier. I shouldn't be afraid to type more. I can afford the carpal tunnel, I'm sure. So here we go. So now we are printing these. And what I'm saying is that it'd be nice to know what those letters are, right? Rather than having to go A, B, C, D, E, O. You get what I'm saying? So we'll go ahead and do that. So what I'm going to do now is I'm going to say, hey, what letter is that? CHR, to create a letter. And it's going to be the index plus ord A. Kind of see how it's the reverse of what's going on over here? Right? I subtracted A, and now I'm adding A back in to figure out what letter that should be. I use this a lot in cryptography when I'm doing any crypto work. So anyway, as a result, we've got a nicer table here, where we've counted A, B, C, D, E, F, G. So everybody kind of knows, we just kind of know without, and we don't really remember necessarily when we've been taught that E was the most common character in the English language. It's just like one of those facts that just kind of osmosis into your brain unasked, right? If you're a native English speaker. If you're not a native English speaker, this could be complete news to you, and I'm glad to fill you in on that, right? And it's very unsurprising that there's not many Zs, not many Zs, right? J, most people don't think about that, but you don't see people jumping for joy too much in texts, unfortunately. I think the world would be a better place if we did that a bit more often, okay? Q doesn't appear too often, unless we're talking about articles about Qatar, which, as I mentioned on Discord last night, we somehow are able to read Qatar, right? Qatar. We read this word after learning in English, right? That all Q's are followed by a U, and you pronounce it qua. And then you somehow see Qatar without a Q, and you know exactly how you're going to pronounce it, even though you may never have heard the word pronounced before, and you can pronounce it perfectly well. It's weird how that works. Anyway, so this works. We can also be a bit more exact and say, hey, letter is equal to, let's say, letter is equal to letter dot lower, to make sure that we're counting both uppercase and lowercase letters. Right? Okay, now to just kind of hit you with a flaw in this plan. This works great for what we're doing here. But if I change this problem to something else, which is, what is the most common word in the English language, in the document? What is the word count of this? Then suddenly we're in a heck of a lot of trouble, right? This does not work for that, because we just basically made one slot for every letter. Or let's even not change the question, but change the document's language. What if we had to do this on a document in Mandarin, right? In Chinese. Suddenly this doesn't work. Remember, there are thousands upon thousands of characters in a lot of the Asian languages. Okay? This is not going to work for that. So what I really would like is an ad hoc way of doing this. Basically saying, given a document full of arbitrary symbols, figure out what the most common symbol is. Okay? So what we need is the indexes to be flexible. And that's where we get into our pal, the dictionary. Now, the dictionary here isn't what I'm referring to as like the dictionary that you pick up and read. But that is a good analog. With a dictionary, you have a word and a definition. In Python, we have something, the dictionary performs a similar function. You give it a key, you look up the key, and it tells you a value. Just like how in a real world dictionary, you pick it up, you look for a word, and it gives you the definition. So a dictionary is declared, so if a list is declared like this, L is equal to braces, square braces, our dictionary D is curly braces. So congratulations, you have joined the elite group of people who actually use these symbols on the keyboard. These symbols are what we use for, these curly braces are what we use for dictionaries in Python. You access those on a standard English keyboard by shift and then square braces. Okay? This defines an empty dictionary, which is actually a lot more useful than it seems. Dictionaries are used for creating mappings, for creating functions, on-to functions, I think is the mathematical term. But basically what they are is that they are arbitrary key value bindings, one way. So, for instance, if I ask for the key of 0, it's going to give me a key not found error. So you use these the exact same way you would with a list, by the way, right? Whoops. It doesn't give me so notice it did not give me it did not tell me, hey, that syntax isn't valid. It told me key error. A key error is the equivalent of, if I were to do this with a list, where I create an empty list and then ask what's at index 0. Okay? So the terminology is, lists have indexes and dictionaries have keys. Make sense? Keys are a bit more flexible. Keys can be, when we create a list, the indexes of a list are always in order, right? Right? The indexes are always 0, right? And so on and so forth. Keys can be in any order, and I can just create them on the fly, right? If I try to say, hey, we've got an empty list here, right? L is currently an empty list. If I try to say list, hey, index 0, that's going to be 17. Or I'm going to store apple in there. Let's go with that. It's going to say, hey, that's out of range because we don't have any slots created yet. Whereas for a dictionary, well, you're creating bindings, arbitrary bindings. So if I say, hey, dictionary, key of 0 is apple. It's going to be perfectly happy with that. And when we print it now, we get this. Rather than an empty curly brace, it gives me this format where it says begin dictionary. So those curly braces represent beginning and ending of dictionary. And we have the key, colon, the value. And this says that if I ask the dictionary for this key, it's going to give me the value apple. It does not work the other way around, which is great because that means there's less for you to think about, right? It means you don't have to remember what those values are, right? If I ask for the value, if the key apple, that looks weird, doesn't it? If I ask for that, it's just going to tell me, hey, that's a key error. I don't have to do this in any particular order as well. I could say D5 is equal to, I just hit the enter key a bit too early there. D5 is equal to banana. And D, I get 0, apple, 5, banana, yes. Question?
Kind of like test 1 almost?
What?
Kind of like test 1?
Kind of like test 1?
Like, with like slices?
In what sense? I may be missing the connection.
So like you had to...
I know for test 1 you had to like figure out slices to figure out, put together a message.
Yeah.
Yeah, the syntax is very similar, but we cannot do slices because order does not kind of matter, right? Order is the thing we sacrifice. So, if I ask for D5, I'm going to get banana. If I ask for D0, I'm still going to get apple. If I ask for D3, it's going to tell me, hey, that key doesn't exist yet, right? It only puts in what you tell it to put in. typically, you're not using numbers as your key, actually. EU is equal to durian, which if you've ever smelled that, you know why. So almost anything can be a key. So the power of dictionaries is pretty much anything can be an index, okay? Now, I teach these heavily in 2168 when in Java. In Java and in other programming languages like C#, we call these hash maps, referring to the function of hashing a key so that we can turn it into an array so we know where to store these, and it becomes this whole thing. These are actually really efficient data structures, and they are extremely powerful. So for 1051, let's just kind of go over where we use these, okay? What kind of things do we use them for, okay? First and foremost is arbitrary key value storage, like a mini on-the-fly database, right? Typically, you basically have some unique identifier, like say your Amazon, the unique identifier for your customers is going to be their email, because people have same names, they can have same addresses, they can have same all sorts of other stuff, but the email account they sign up with is going to be unique, right? That's the thing you prevent them from having duplicates of. Yeah, sure, a person can make multiple accounts, but whatever, okay? So the key there would be their email address, and their account information would be basically everything about them would be their value, right? So arbitrary key value pairings. Typically that says an ID of some kind and get you that. In school, that's like your TUID or something like that, and the value would be basically all the data that's required for you. Okay. The second and very common usage we use in programming is counting. Counting arbitrary things, the problem we were just going over. So in this case, for the problem of counting, we use the key as the thing, right? In this case, we would use the key as the thing and the value as the number of times we've seen that thing. Right? Key as the thing, and the value is the number of times we've seen that thing. So we can use this to say, hey, if the key is A, the value is going to be how many times have I seen A, if we're doing a letter frequency count. If it's B, that's how many times I've seen B. If we're doing a word frequency count, we can say, hey, the word and. This is how many times I've seen the word and. Make sense? So that's super useful. And then the last thing we're going to do, which we don't do in this class, but we do in 2168, is the problem of categories. Okay, and this one's a bit weirder, where we have a thing as the key. We have a category as the key. So that's typically like a string or something, like the name of the category. And then this is where it gets weird. So when we do categories, right, it would be like you have the thing, and then you have the list of all the things that belong to that category that you're looking at. So for instance, if we're going through and we're trying to classify like parts of speech in this document, right, the category might be nouns, and the list might be the list of all the nouns that we have found so far. So it's a bit trickier. If you look up the Cheater's Hangman puzzle I've referred to that we do in 2168, and that one uses categorization. I may have mentioned it there. Sometimes the two classes blend together. So let's go ahead and see how this works in practice over here. Okay, this becomes a lot easier, by the way, a lot shorter now. Let's just see how it works and kind of see it in action. Okay, here's my counts, but my counts is now going to be an empty dictionary. And we're still doing the letter counting, by the way, except now it's going to be counting all possible symbols in our document, every single one of them. Our counts is equal to this, okay? And this loop, pretty much if you memorize this loop, this answers a ton of the questions. This answers the dictionary question in on exam 2, essentially. For a letter in text, if letter in counts, or actually I'm going to do it like this. If the letter is not in counts, we'll do it like that. So what does that mean? Well, let's go back to our IDE over here. D0, right, was apple. You can ask 0 in D. Is 0 in the dictionary? Yes, it is. Is 1 in the dictionary? No, it is not. It's not a key in the dictionary. Is apple in D? It's only going to check the keys. Apple is not a key, right? But EU in D is. So basically we're asking, is this a key yet, right? Is this a key in the dictionary when we ask in? So here, if we're asking if it's not in, we're basically asking, have I seen this letter yet or not? If I have not seen this letter yet, well, how many times have I seen it now? I've seen it once. So that's exactly what I'm going to do. I'm going to say counts of this letter is equal to 1. Make sense? So if I've not seen this letter before, well, I've seen it once now. And so I'm going to put that down. Else, well, my options are I've either seen this before or I haven't. There's 2 options there. There's no third way to cut this. So if I have seen this one before, what I'm going to do is I have to change the number of times I've seen this, which is the counts of the letter. We know this, right? We changed it to 1 over there. Now I've seen this letter before. So what I'm going to need to do is just increment the number of times I've seen that by 1. Let's go ahead and make that a bit more explicit. I'll get the number of times I've seen it previously and add 1 to that, and then store it, and then overwrite the value. With a dictionary, whenever you store a new, this is technically storing a new value, you're overwriting the previous value that you had. But, so basically what we're saying is, if it's not a key, make it a key, and say we've seen it once. Otherwise, we've seen it, and so we take the number of times that we've seen it and print that out. What we're going to do now is just simply print our dictionary to kind of see what madness we have accidentally unleashed upon ourselves. Okay, so first is the kind of the reason I have to do that encoding thing, because the first thing we find is a hidden character, slash ufuf. Okay. And that's 1. That's basically a begin the file character. Then we have capital T's, 925, lowercase h's, 180181, then E, and if you actually read this, it comes out as THE, the space, project, gun, because it can't do Gutenberg. Why isn't it doing Gutenberg? Because the order in which it will actually be Gutenberg. Yeah, no, it has a T already. The order in which it prints out the keys is the order in which it sees them. That's the order that they get printed out in. The order in which it added the keys to the dictionary. So we now have a count of all these characters, and it's a pain to figure out which one occurs the most. It's not too bad. There's like a way to print out the sort to sort it. That was almost bad. It is crazy how good humans are at catching and throwing things. It's like one of the things we are evolved to do, like as a specialty, catching and throwing. So, accidentally knock something over, your brain will track it and figure out where it's supposed to be. All right, so this is pretty nifty. And again, this works on any arbitrary characters. Let's go with a cat emoji, okay? Because remember, cat emojis are characters as well. Just simply take this one, and I'll just, can I drop it in here? Yep, there. I'll drop it there. Instead of the old sea dog, we're going to do the old sea cat at the Admiral Benbow, the sea cat, the last of the blind cat, the cat's papers, I go to cat, the spy cat, what I heard in the apple cat, the attack. Let's see. I strike the jolly cat. And then I'll just put a few random cats in this document, okay? Because why not? They get up to trouble. Save. And now if I run this, right, and we're using the cat here in place for like a Chinese character or something like that, or whatnot. And you can see that this works on the cat because emojis are Unicode characters. They are just text, right? If I say, hey, what is the ORD of this character? And, the font basically renders cat like this as opposed to the fun way of doing it. That's apparently character 128008. And similarly, I can ask, hey, what is 128009? What do we have after you? It's looks like snake or dragon, serpent. Let's find out. No, didn't copy that, right? Copy. That looks like dragon. Not too bad of a guess based off of that. That's actually, yeah, it's a dragon. Sure. Eastern dragon. Anyway, but yeah. Yeah, sometimes referred to as a Chinese style dragon. I always, in D&D games, people like refer to them as the Eastern style. Since Immersion says we're not going to call that thing as a Chinese dragon because this is a fantasy game. There's no America, there's no China, there's no Antarctica. Right? It's a fantasy world. I need to play D&D again at some point. Okay, so how are we going to do this now for that kind of word count that we can do? Okay? Because I'll leave printing them out in kind of a sorted order for a separate exercise. You can kind of look up how to do that. It's one kind of command thing. But let me kind of just emphasize. Me, the guy with the computer science PhD, says I have to look this up every single time. So I don't keep it in my memory. It's not a big deal. Once you have the data, it's, the analysis of it is kind of a different question. So I'm going to go ahead and continue on with this. I will comment out everything I've created so far, except for this, because I'm going to go ahead and just do my old text is equal to data.read lines, and we're going to read one line at a time. Now, the reason I'm doing this is because I want to now change this up to let's look for the most common words, okay? So how would I do this for counting up words? So I'm going to go line by line because I definitely know how to do that. So for line in text rather than for letter in text. And I could put letter there, it just wouldn't make any sense. as a variable name. It'd be perfectly valid. It's just, I like my code to try to be as sensible as possible. And that's something you just get better with at time, hopefully. So for line and text, what we're going to do is, and I have no idea how my cats are going to mess with this, but that's actually a hilarious idea. Okay. What we need to do here is we are reading each line. So let's go ahead and clean up the lines a bit. Line dot is equal to line dot strip. Get rid of that beginning and trailing white space. Okay. That should run. Great. And then we're going to go line is equal to line dot lower to make sure that everything is lowercase, because I don't care the difference between uppercase and lowercase variable. Okay? Now we're ready to start counting. So we're going to create our counts variable, and that's going to be our dictionary. The key is going to be the word, and the value is going to be how often I see that, I've seen that. Okay. This semester, I might make one of the questions to choose a dictionary question on the final exam. I guess the time to make an aside before we get back to this. So I've alluded to this in the past, but the final exam, the way that works is that and I'll explain this again in the future when we get closer. You have I give you 7 questions. I've been doing this since COVID, okay? And I've found that this works really well. 7 questions, and you choose 5 of them, okay? And you get to choose which 5 you want to do. Each of them is worth 20 points. So it's a fairly short final exam in that regard. Each of them has a rubric which also kind of provides step-by-steps. You'll get more since the second and third exam have more programming on them, you'll get more and more familiar with those programming rubrics, because those rubrics also double as a how-to on the problems. The topics, I typically tell you the topics. The topics are generally file reading, nested lists, turtles, Monte Carlo. What was another one I'm trying to figure out? Something like that. I also include, I cannot remember for the life of me what the fourth one is. Oh, right, regex. So the past has always been like this. Regex, Monte Carlo, you know. So this one is, so this one, if you know, you print out these numbers using a for loop, but if we hit that, and that's the one I might replace with dictionaries this year as a dictionary problem. And then finally, the last, I think that's going to be better, because this year I'll probably replace that with a dictionary problem. And then the last one, I call the mystery question. It's one of my favorites, because what I do with that one is, it's one of my best questions, to be honest. I don't tell you what it is in advance, except that it's not something I teach you in class. What? How's that fair? How do we have a question on the final exam that we don't teach you in class? Well, the answer is I give you all the documentation you need to solve the problem. So I say, hey, this thing is built into Python. Here's the commands on how to use it, right? So I say, here's this. We haven't learned it, but here's everything you need to use it. Here's a problem that you commonly solve with this one. Solve it, right? And basically it's a tool that's tailor-made for that problem. Does that make sense? So basically it's the kind of assumption, it's like if I told you, okay, how to do dictionaries, right? And told you each of these commands, except it's simpler than dictionaries. Make sense? So basically I kind of just wrote down all the notes for this lecture on a page and then said, on the next page, solve this problem. except it's way easier than that. Promise you. And pretty much every student who chooses that problem has gotten like 20 points out of 20 on that one. Historically, it's been a good problem for anybody attempting that one. So anyway, the final exam works like that. So I do try to make it fairly easy for students to kind of choose the things they're comfortable with. All right. So now going back to reading this. So we're going and reading word by word. So we want to read all the words. So for every line in the text, we strip it so that we remove the trailing beginning and white space, and then we remove and then we make it all lowercase. Now, the big thing to understand about words, at least in English, okay, it's a bit trickier for other languages, for the non-Latin-based languages, but English separates words by using spaces. Other languages don't even necessarily have spaces between their words, but English definitely does, and so that's how we know how to split these things up. So what we do is we say words is equal to line dot split, and we're going to split on a space. Okay? One space equals word. So for W in words, and then we do the exact same if-else statement we asked before. If W not in counts, if we've not seen this word before, then the count of that word is now 1. Else, count of this word is now equal to the previous count of that word plus 1. Run, it compiles, run, well, it doesn't compile because it's Python, it doesn't compile, but it ran. And now we have a large tally of all these words. Oh, there's the cat, 5. 5 cats by itself. If appears 211 times and appears 286 times, recognize this as one word, so this, which probably appears the most, is 4,540 times this appeared. Occasionally you get things that aren't well digested, but that's okay. Sea cat, cats, spy cat. But anyway, so now we can go through and we could probably do like a count of the most common words and stuff like that if we needed to. All right. So anyway, let's go ahead and go to Canvas now and kind of briefly talk about the next problem. Okay, and then that will be it for the day. Okay, so I'm going to briefly go over the next homework, and then that will be it for the day. Okay. Since it is 3:06. The next lab assignment is Hawaiian pronunciation. This is a fun assignment. I enjoy it a lot. Okay? And if I need to, and this is one of those ones that basically, depending on your workload, please let me know if I need to push back the due date on it, okay? Because I can be flexible on this one if I need to be. Like a lot of my assignments, I blatantly stole this from another professor because we share our materials with each other to use, because why try, when we find a good assignment, we should share it. So Kendall Bingham created this one. Hawaiian words can look, and what this is a program that will be used to type in a Hawaiian word and you get the pronunciation of that Hawaiian word. Now, words in Hawaiian can be very intimidating, like humu humu nuku nuku apua. That can be a very intimidating word to look at. But if we give you a phonetic guide, it looks a lot less scary. Humu, humu, nuku, nuku, apu, a. Okay, and for those of you who are wondering what that is, That is this. It is the Hawaiian state fish, the reef triggerfish. It is quite beautiful, in my opinion. Yeah, Hawaiian name Humu Humu Nuku Nuku Apua. The triggerfish with the snout like a pig. So the Hawaiian language is we're going to be using Hawaiian not just because it's getting warmer, but because it is also a relatively simple language for this exercise. It consists of only 12 characters, as opposed to English's 26. The five vowels that we know, A, E, I, O, U, and 7 consonants. Those 12 characters are A, E, I, O, U, P, K, H, L, M, N, W. For most of these are pretty simple. P, K, H, L, M, N. They're pronounced exactly like you would in English. So you're pa, ka, ha, la, n. W's are pronounced either as W's or V's, depending on context. But we're only going to pronounce them as a V if they're after an I. So, otherwise they're a W. Vowels are pretty straightforward if they're by themselves. And if you've learned any kind of Japanese, this is exactly what Romanji is like, which is A sounds like A, Austin, A, E, O, U, right? So you've got A, E, O, A, E, O, U. More. I, U, L, sometimes. So anyway, so when you see an A by itself, it's only ever pronounced as an A sound, never as an A sound. Okay? E's are always S sounds. I's are always pronounced as an E, like in B. O's are always as the letter itself, O, and U's are always like oohs. Okay? So aloha, we all kind of know that word just through osmosis. Aloha. So the catch is the double vowels. Okay? And this is true, and this works exactly the same way in a language like Japanese as well. Okay? Which is that when you pronounce when you get two letters together, it's not A-E, it's I. A-E as well as I. A-O, A-O is not A-O, it's ow. Now, if you're wondering why, it's just because of dropping syllables and dropping the way that syllables combine together. For instance, A-E, 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 A-E. Okay? Just becomes A-E if you keep saying it quickly. A-E becomes I if you basically say it quickly enough and don't distinguish between them. So that's how it becomes I over time. Okay? So, for instance, so there's all these rules to implement. Not too many of them, though. They're pretty easy. The word keiki means child in Hawaiian, but E-I, as we hear of this, is A. So you don't pronounce it as ke-e-ki. You pronounce it as keiki. Okay, and in fact, this is the word I will be testing your program with. Because the most common issue we have is students, they turn it in, they think it works, and I test it on keiki, and I don't get a two-syllable keiki, I get ke-e-ki. Ke-e-ki-e. Ke-e, or ke-e-ki, yeah, that's how I get it, keiki. Similarly, Maui is Mau-e, because you only get pairs of vowels. You don't get triplets. Okay. And then finally, they note it's not all combinations are represented. For instance, you don't have an O-A pair, in which case you just do O-A separately. Okay. So there's plenty of these things, and there's more rules to these. But the way this will work is here's the rules for how this will work, but your output's going to look something like this. Enter Hawaiian character word to pronounce, invalid. V is not a valid Hawaiian character. enter a Hawaiian word to pronounce aloha. Aloha is pronounced aloha. Do you want to enter another word? Yes, no. Sorry, why, yes, and no. And then instead of entering one of those choices, they try to do humu humu hunu huapua, in which case they say, you actually, no, you got to do yes, no, N, or O, and then they do that. So basically, enter the word. Do you want to enter another word? If it's multiple words, it will handle that, which is actually easier than it sounds. Okay. Now, the big kind of pitfall here is that you kind of want, is that the instinct is to use a for loop and go through every character one at a time. This is actually one of those rare occasions where you want to iterate over something using a while loop. Why? Because you'll need to figure out, hey, am I looking at one character or a pair of vowels? That's what you got to figure out. Similarly, you won't be able to just use the replace method because you'll need to replace multiple times. Replaces characters with one character with another character. But here, if you're trying to replace one character with another character, you're going to overwrite characters you'd previously replaced, which becomes a bit of a headache. Okay, it's a bit of a linguistical knot. Now, we only have 6 minutes left, and I will go into more detail on this assignment on Tuesday after you get more of a start on it. But I will say this. Okay, you want to have dictionaries up here, right? You want to have dictionaries of some kind. And then before you even think about trying to loop this together, trying to do this full loop of enter a Hawaiian word, before you do the IO, right, we have two functions we need to write. Okay, we have basically two functions, and then after that, everything is just a wrapper for these two big functions. What are these two big functions? Well, this first one isn't too bad. Validate, which returns true or false, and given some word, tells me whether or not it's a valid Hawaiian word. Make sense? This just simply says, hey, can I even attempt to pronounce it, right? Make sense to everybody, right? So that's the first part of the problem. And then the other big problem we have, the other big sub-problem to this, is the actual pronunciation, which we'll just do as pronounce. Given a word, we attempt to pronounce the word. But here's the thing. By separating these two tasks up, the validating if it's valid, and then pronouncing it, we can go ahead and basically assume that the word that we're going to try to pronounce is a valid word. Okay? So these are two separate jobs. Checking to see if it's a valid word to pronounce versus actually pronouncing it. So we validate it, and then pronounce just basically assumes, hey, this is a valid word. I'm going to try to pronounce it now. Okay? So that is pretty much it. It can be a bit of a tricky one because it's going to require you, again, to iterate over this with a while loop, something like this. Index is equal to 0, right? Index is equal to 0 while index is less than length of the word, right? And then you have to manually increment that index based off of how many characters you're reading. More details on this on Monday. I know some of you are still working on the hurricane tracker, and I definitely would want you to finish the hurricane tracker first. Okay? So with that, it's 3:17. Please stay warm and, don't slip. It's slippery. It's going to be slippery. So please stay safe, stay warm. If you need me, right, please let me know. If you have to demo that one of the missing assignments, let me know. We can arrange to demo it over Zoom tomorrow sometime.